Hi, Advitya. So how did you get into data science?
Hi, Kirsch. Thanks for having me. Um, so data science was a new major that was introduced in my college when I was a freshman, and I got to know about it before I entered college. And at that time, I didn't really know what data science really was. I was kind of curious to check it out. And just to give you a little bit of background here, because there's a slightly funny story about how I stumbled upon it. Um, I applied to UC San Diego with like an engineering sciences major, and I got into UCSD for this major, but 10 days after my admission offer, that major kind of got canceled for some reason. And I automatically got structured engineering as my major. So I had come across data science before starting college, and I was kind of curious to kind of explore what it was like. And when I entered college, I did take the first class in structural engineering, but I couldn't see myself working in that field. And I was pretty passionate about math since high school. So I kind of wanted something that combined math with, let's say, programming, because I'd heard a lot about the importance of programming. So I kind of wanted to check that out. And ultimately, I started going on a few websites online to take online courses in data science, trying to figure out what this landscape kind of looks like, learn some of the fundamentals behind analyzing data and writing code and things like that. And ultimately, I just spoke to a variety of people, including academic advisors, professors, upperclassmen, recruiters, industry professionals. And ultimately, I kind of decided to pursue data science as my major.
Yeah, that's really interesting. And I can sort of relate to almost everything you're saying. I'm studying math and computer science in my college because unfortunately we don't have a separate data science major, but it's pretty much the same thing. And then also I've been talking to people. This is what the podcast is for. I talk to industry professionals, people like you who are working now. And so, yeah. So I was going through your profile and you did your undergrad from UC San Diego, as you mentioned. You had a significant impact and you had numerous contributions to that department. So do you want to talk about some of the research projects you've done or your work in the data analytics lab as a deep learning researcher and stuff like that?
Sure. So I had worked in a lab in the CSE department for around like 2.5 years, just kind of volunteering under a professor and learning a little bit about how research is kind of done. My research area, or the research area of that lab, was dealing with machine learning systems, which deals with building systems that are faster, cheaper, more scalable to facilitate a variety of machine learning applications. And within that, my particular project was based on building scalable systems for deep learning, which, just to let your audience know, is a particular kind of machine learning that deals with analyzing unstructured data. And I can go more deep into it later on as well. And that research project was kind of about this particular class of workloads called multimodal analytics. What this means is that oftentimes in the industry, when people are doing machine learning, for example, some of the data sources that they use can be a combination of structured data, which resides in tables, and unstructured data, which can come from sources like images, audio, text, video, etc. And usually they kind of extract features from unstructured data sources like images, they combine them with the structured data in tables, and then they put the combined feature set or the combined data through some ML model. But the way in which they extract those features from the unstructured data sources takes up a lot of time and memory and is very expensive, especially at scale. So that project was really kind of about trying to optimize how you would extract features or extract relevant information in a way out of those unstructured data sources so that it can be a lot cheaper and scalable to train. And I was mostly kind of involved initially in terms of kind of running a bunch of experiments, expanding their API to facilitate different kinds of ML workflows and options for users, things like that.
Yeah, that sounds really interesting. So when you first started working for this position or the research you were doing, what did you exactly do? Because in your profile, it says that you were also doing some grunt work in the beginning. So could you tell us about that?
About the stuff I did before research, or like how I got into that?
Yeah, how you got into research, basically.
Sure. So initially in my freshman year, I was working for this startup, and I was just working on some data science projects. And I had come across that research lab technically before college, because the professor working in that research lab happened to be a friend of a family relative of mine. So I kind of like also had reached out to them while I was making while I was trying to make a decision about on the college that I would go to. And I had come across their lab while I was exploring data science, and I saw that they were kind of doing pretty high tech work related to that at the time. So in my sophomore year of college, I got to see in a newsletter by the academic department once that there was a lab tour that was going to be held specifically for that lab. And I really had no background in machine learning systems or in any of the research work that they did, but I was pretty interested to check that out. So I went to the lab tour. I got to interact with the professor and their PhD students. I learned a lot. I learned about some of the work that they've been doing. And then after the lab tour, I just reached out to the professor and I said that I'd be pretty interested to potentially join the lab and kind of like help out in any way I can, and also get a bit of experience while I'm at it. So ultimately, I just sent him my profile, and then we had a long conversation discussing about my interests and what the lab's work is kind of all about. And then I also got to read some of the papers coming out of that lab, and I ultimately choose a project to be part of. So really the way that I kind of got into a research lab without having any experience whatsoever in research as a second year undergrad was really to just kind of show initiative by reaching out to the professor, kind of showcasing interest in particular kinds of areas, and just trying to be curious and trying to kind of learn about different areas there are, and kind of just trying to contribute in any way I can to build more experience.
Yeah, that's actually really important. If you're listening to this, you should take a note of it. Just reach out to a professor whose work you're interested in, and definitely you can like get into their research, help them out. Right. So another thing, you were also a guest speaker for a graduate databases seminar. Do you want to talk a little about that?
Sure, yeah. So there was this graduate level seminar course that kind of dealt with databases and database systems and things like that, where every single week, some person would usually kind of come in and present about some of the work that they've been doing. And that can include like industry professionals, professors, graduate students, and things like that. And because I was in the research lab that I was talking about right now, um, I got to know that there was this seminar that was also kind of being held. And um, in a lot of cases, some graduate students also use that seminar as a platform for doing practice talks before they have any major talk coming up. And at that time, the project that I was doing with the research lab was associated with a scholarship program, with a research scholarship program. And there was a final presentation associated with that. So I just reached out to my professor and I was like, if I could get to present in that seminar, because I could get to present in front of graduate students and professors, and really kind of treat it as an initial practice talk before the final presentation of the research scholarship program kind of happens. That not only helped me kind of practice, kind of gain some initial practice with my talk, trying to get some feedback on the presentation, but also kind of expose other graduate students to some of the research areas that my work was also touching upon.
Yeah, that's great. So you were working on the project, and this is the same project you were working on that you presented in the talk,
Yes,
right?
yes.
Right. So what all did you cover? How did you structure the talk, and what all points did you cover from your research?
Yeah, that's a great question. Even before I kind of made that presentation, I was also pretty curious about how these kinds of talks are structured and how do you cater to a broader audience? Because even though there are a lot of graduate students and professors in there, research areas can be very specific in nature. So not everyone may be exactly acquainted with everything that you're discussing. There were two things that really helped me. The first thing was literally just watching some of the practice talks and actual talks given by professors and the PhD students of my lab to kind of see how they structured their talk. And what I learned out of it, which I tried to apply in my talk, was related to trying to follow a coherent storyline on how things are the way they are currently right now, what are some of the challenges, and how you're trying to mitigate those challenges. To be more specific on this, the way that I personally structured my talk in my case is I kind of introduced this area of deep learning to my audience, saying that this is a particular kind of machine learning, which is gaining a lot of traction and is being used in several industries. And there are these kinds of workloads like multimodal analytics workloads, which are also very important and very powerful. But the overall end-to-end ML life cycle, the machine learning life cycle, dealing with these kinds of workloads can be very expensive because of several reasons. And so we are introducing this new system which can mitigate those challenges and trying to kind of establish a coherent storyline to make the motivation of the talk very clear seemed pretty important for me to follow as a template, where I talked about new system that we would be building, some of the contributions that I made as a research assistant, because I was definitely not the major guy kind of working on that project, but I was assisting some PhD students and the professor that I worked with. And I also talked about some of my experiments and those results and how they further motivate the problem and what our ultimate goal with building that system is and how it kind of fits into the grand scheme of things that my research lab is also working towards. So those were like some of the components that I tried to cover in the talk. It was only 10 minutes long, so I had to also time box it that way.
So that must have been a great experience for you sharing your research with all these people who are working in different fields. Um, I also want to talk about deep learning. You mentioned that that was a part of your research. So let's just start from the beginning. What is deep learning?
Yeah, so deep learning is a particular kind of, or a particular class of machine learning that kind of originated with following the principles of how the human mind works. So we know that the human mind has neurons, which are used to propagate information, for example. So deep learning kind of utilizes artificial neurons or artificial neural networks, which are basically, let's say, a sequence of numbers or vectors or matrices, and you're trying to propagate information by doing a variety of data transformations on your data to represent or extract different kinds of information about the data you're dealing with. Deep learning is particularly used to analyze unstructured data like images, audio, text, video, geographical coordinates, etc. And it is supposed to be incredibly powerful in that the users don't have to specify like very task specific algorithms for deep learning, but deep learning is powerful enough to kind of automatically learn or infer different representations of data to kind of encode different pieces of information about their data. As an example, if you take an image, a deep learning model has the ability to kind of take the mathematical representation of that image and try to infer what some of the higher level features or the lower level features would look like. A higher level feature can be something as the digit, or let's say a number written on the image. A lower level feature can be something like considering some of the fine-grained edges which separate different objects or entities in that image. So rather than training a model explicitly to recognize some of those things, deep learning with the kinds of data transformation that they deal with already has the capability to infer a lot of the higher level and lower level information, some of which human beings may or may not even be able to detect. because of which it has performed incredibly powerful and perhaps even better than human beings in several tasks that human beings may implicitly perform on a daily basis. Let's say recognizing objects, for example.
Wow, yeah, that's definitely a great resemblance to the neural structure of humans. And so you were talking about some applications of deep learning. There's pattern recognition. It's used for stuff which is unstructured, so images and just things like that. What other applications of deep learning are then something that we might have noticed in our daily lives?
Yeah, so one application that pops into my head is, let's say if someone's driving a car, right? And there are a variety of real world phenomena that kind of happen while you're driving a car in terms of observing pedestrians, or let's say the traffic light, and obeying the traffic rules and all of that. So there are a lot of considerations that a driver has to make while driving a car. And another hot area related to deep learning, it's definitely not perfectly solved just yet, is related to self-driving cars, where drivers can essentially be in a way fitted with sensors or computers that can in a way see what the environment kind of looks like, which can kind of take on that video data or kind of record the video of that environment and then try to detect different kinds of objects and accordingly kind of decide what the speed of the car should look like, when should the car take breaks and things like that, how to kind of incorporate pedestrians walking around or obeying the traffic signals and things like that. So it's really applications like these and many other, recognizing images and things like that. Let's say kind of recognizing satellite imagery, trying to predict if particular areas can have forest fires and things like that. So there's really a lot of real world phenomena which humans can perform good or decently well at, which deep learning tries to really augment and automate and potentially even perform better at, to kind of like reduce human efforts and also kind of augment the overall decision-making process.
Right. So these models are built to basically learn from themselves in a way. And what's the learning rate like for different types of neural models?
This depends on a variety of factors. First of all, this depends on the kind of model that you're dealing with and how that model kind of works. Let's say if you're analyzing images versus if you're predicting the next point in time, or there can be different kinds or classes of models that you can deal with, which can have their own pace of learning. Aside from that, there are certain parameters related to those machine learning models, or certain knobs of the models, which are not, the values of which are not really determined during the model training process, but still need to be specified by the user. And those parameters are called hyperparameters. And setting up those hyperparameters turns out also has significant impact on how fast a machine learning model would train, how fast it would kind of converge to an optimal value or an optimal prediction. So it's really kind of this combination of the nature or the amount of how much your data is, the kind of machine learning model related to the model architecture that you're dealing with, and how deep or big that model is, and also related to how the knobs of that model are tuned, or certain parameters are tuned, which kind of determine the pace or rate of learning, or let's say the number of times you see your data, or let's say the kinds of steps you kind of take to minimize some notion of loss.
Right. So it's recommended that basically the learning rate should be determined by trial and error. So it's not too fast or too slow for the model.
Exactly.
So what are some advantages and disadvantages of using neural networks?
So the advantages really are for using neural networks and deep learning approaches is that deep learning is very good at analyzing unstructured data and let's say kind of effectively analyzing large amounts of data. Some of the classical machine learning methods haven't been as great with analyzing structured data sources, for example. And deep learning has made it incredibly effective to kind of, as I said before, automatically infer different representations of data and extract different kinds of features without the users explicitly needing to program to do so. So it's incredibly versatile in what it can do because it doesn't require a lot of explicit programming, but it just requires a few building blocks in terms of the kind of model architecture and the kind of data you're dealing with and some of the intermediate inputs and outputs, where it can automatically kind of detect different representations and automatically kind of choose which representations would be important. So really the kinds of applications that deep learning can deal with are very versatile, which is the advantage. Some of the major disadvantages with deep learning is that it requires a lot of data usually to train, and it's very costly to train deep neural networks because at the very foundational level, deep learning is really dealing with a bunch of vectors and matrices, which is basically a collection of numbers and a variety of mathematical operations dealing with those numbers. We are literally talking millions, if not billions, of numbers and mathematical calculations and computations that are kind of happening at every point of time while a model is training. So it takes up a lot of computational time. It takes up a lot of computation resources, because of which it takes up a lot of like monetary costs and electricity. So there are also environmental concerns and other kinds of things with that. Another area of deep learning, another area related to deep learning, which hasn't been mitigated just yet, is kind of like the kind of data that you kind of pass into that, because ultimately it's a machine. If you don't put great data in, you may not get great data out. There's this kind of saying, garbage in, garbage out, which basically means that the quality of your data needs to be really good. And if there are, let's say, biases in data sources, a deep learning model would also kind of exhibit those biases, which can lead to a lot of ethical issues as well. So it also needs human intervention in terms of how you define the models, what kinds of data you kind of pass it on. So there needs to be some considerations. Last but not the least, another disadvantage with deep learning is really related to interpretability of the models. For example, it is used in a lot of healthcare or medical applications, let's say to detect something like diabetic retinopathy or diseases like that, or let's say detecting pneumonia from some image scan, from some X-ray scan of lungs. But even though it may even end up performing even better than humans on some of those tasks, even after that, it is still kind of tricky to rely on a model or a machine when there are lives at stake. Because what if in the off chance that model kind of incorrectly predicts some kind of disease, that can have real life consequences on the users. And so those are one of the reasons where deep learning, those are one of the reasons which is kind of in a way sabotaging the adoption of deep learning truly in the scale that it can kind of be considered to adopt, because there can also be lives at stake. And so there are real world considerations that need to be made by humans as well.
Right, and sort of building onto that, there's also there's a well-known disadvantage, the black box aspect of neural networks, because you don't really have an idea of why something is like why it's giving out a certain result. And I think that's one of the reasons why it's at such a disadvantage, because we can't use it where lives are at stake or something more, I don't know, something more important is at stake, because we don't really know why it's coming up with that prediction. So is there some, I think causal inference is a new subject, a new field that is sort of tackling this question of trying to answer why stuff is being predicted the way it is. So do you have any experience with that?
Actually, I don't have any experience with causal inference. I have heard a lot about it, but like from some very surface level information that I know about it, it seems to be related to considering a variety of real world and external factors that can kind of be related to whatever output you're trying to predict. And it's kind of trying to control as many of those real world factors as possible to hopefully kind of showcase some degree or notion of causality between your input and output so that you don't fall into the rat hole of correlation not implying causation kind of notion in there. I think it probably involves a lot of economics and statistics, and it's its own area of research and practice altogether.
All right. Yeah, thanks for sharing that. So I'll just direct my questions towards deep learning then. And in deep learning, as we mentioned before, that there are certain biases that may exist. And I think data normalization is something that is used for that, or maybe it's used for something else. So do you know anything about data normalization?
Yeah, so this kind of gets into more of the math behind deep learning, and I'm going to try to keep this high level for the audience as well, where essentially the principle is you want to make sure your data is kind of operating on a similar scale. You want to make sure some of your data is not so out of scale that you get into different challenges related to calculating specific kinds of gradients or specific kinds of step sizes to kind of go down a loss function. So there are several approaches that exist to not only make sure that your data is kind of within a certain range to make mathematics, to make math or computations with those a lot easier, but you also have to make sure that you don't end up overtraining or overfit on the particular kind of data that you've been trained on. So it's also about kind of making sure that your model can still make relatively generalized predictions and not be over biased with the particular samples of data that is being provided to them.
Right. And some of the mathematical stuff behind this, I think it's more of like rescaling and then mean normalization and stuff like that.
Yes, there are different kinds of approaches like batch normalization. There's also approaches like dropout, by which you can disable certain parts of a neural network in order to avoid overtraining. There are different challenges as well related to vanishing and exploding gradients, which means tackling like very small or very large values in gradients, which can make it a lot more difficult and a lot more time consuming for a machine learning model to train and converge onto an optimal value. So there's a lot of those there's a lot of those constraints for deep learning that exist, which can be motivated by hyperparameter tuning and by kind of making sure that some of the knobs that you're specifying for your model do kind of end up to a good value. To be very honest with you, it is more of an art than a science, because hyperparameter tuning itself is a very wide area of research altogether, where we try to find more optimal algorithms to find the best combinations of those knob values or of those hyperparameters in order to mitigate a lot of these challenges that I was talking about.
Right. And that definitely makes sense. That line you said about it being an art and not exactly a science, because I think that's also a debate that some people have with pure mathematics. Is it a science or is it pure art or stuff like that?
Mm-hmm.
Right. So now I wanted to talk about your undergraduate major, which was data science at UC San Diego. So what exactly did you learn? How was it structured over the different years? And what did it help you with now that you're working? So did that theoretical stuff really create an impact, or is that something people could learn on their own?
Mm-hmm. Got it. So I'll kind of break this down into two parts. The first one was what the major consists of, and the second one is how it prepared me for my job or life after graduation. So first, related to the major, the data science major was a lot more specialized than the typical computer science major. Pretty much all of the major courses that we dealt with kind of discussed various components of the data science and machine learning lifecycle in great detail, related to discussing some of the foundational principles, data structures specifically related to data science, different kinds of theoretical foundations, the math behind machine learning, different kinds of applications, data cleaning, data management, data visualization. We had specific classes. We basically had classes specifically catered to all of these sub areas and subcomponents within the data science machine learning lifecycle that I got to kind of explore. So a lot of the major coursework was very specialized. We were kind of dealing with classes from the math department, the CSE department, and the data science department, which was newly made. So there was a So there was a new series of courses which was specifically made for the data science major. And even with the math and CS courses that I got to take, were all pretty specialized towards a variety of those data science components and a variety of those data science concepts. So it was really kind of going into detail about various components of the data science lifecycle. And towards the end, we also got to take electives where we got to explore different kinds of domains within data science. That can be anything related to signal processing to even kind of economics, and we also got to deal with scalable systems around data science in terms of how do you actually make data science and machine learning work applicable in the real world, and how you kind of scale things up and actually make it accessible to the end user and things like that. The second part, which was related to like how it kind of prepared me, was that initially a lot of my experience was centric to data science. But towards the end of college, thanks to my research experience and the most recent internship I did, they were kind of more across ML engineering and ML systems, which dealt with building large-scale software and systems and infrastructure to augment and accelerate data science applications. And so while I was really building software and systems related to that, and even right now, as I'm kind of in my new role as a ML engineer, really having that foundational knowledge about data science and what it's like for a data scientist to go about the overall life cycle of analyzing data and building ML models kind of really helped me as a foundation to kind of like know what the user from my work, which is going to be a data scientist, how they kind of deal with data. And so really having that information firsthand as a data science practitioner myself kind of really helped me provide that foundational knowledge on how data science and machine learning work is being done, and how I can make sure that whatever software or infrastructure that I'm building is going to augment and accelerate the workflow and productivity of a data scientist and the work that they do, so that hopefully my work could impact a variety of data science tasks for a variety of data scientists across a variety of industries, solving a variety of challenges.
Wow, that's a lot of varieties there. So I wanted to ask a few more questions about what you studied in your undergraduate as a data science major. So what were some basic mathematical and computer science principles that you learned in your major?
Okay, basic mathematical and computer science principles. So related to math, it was really kind of centered around learning about the foundations of machine learning algorithms, like how machine learning algorithms actually work under the hood, what kinds of optimization problems they're dealing with, different kinds of loss functions, and different kinds of approaches with which you can kind of generate predictions. So it was about learning the foundations of machine learning, and it also involved a lot of statistics related to that, understanding basic statistical concepts and how they kind of flow into making decisions which can be backed up by data, by statistics, and which can be offered to, let's say, a business-centric audience as well. So those were some of the areas that we got to deal with on a mathematical standpoint. On the computer science aspect, of course, coding was really key to make sure that you can do data science and machine learning work. Having the ability to learn how to code and learn how to kind of program those models to do whatever you want them to do was pretty key. And related to some of the basic CS fundamentals, yes, we got to touch upon data structures and algorithms as well, because they're also pretty important for how you effectively kind of deal with data, let's say in some of the initial pre-processing stages. And even aside from that, in a scalable systems course that I was dealing with, we also got to learn more about the operating system and some of the lower level CS concepts under the hood of the data science and machine learning work in terms of how memory is handled, or how some computations are kind of handled, and how do you make sure that you can kind of take advantage of distributed systems and scalable systems in order to really kind of scale up your data science and machine learning work with, let's say, large amounts of data.
Right. So would you say it was more of computer science principles and just using some parts of basic mathematics, let's say like linear algebra and more advanced versions of topics like that, and integrating them into and just working with data?
Yeah, so like both of these like broader areas, learning about mathematical concepts and CS concepts kind of went hand in hand because data science is a pretty interdisciplinary topic. You do need CS fundamentals in order to make sure you can actually do the work on a computer and make sure that the computer can kind of run the data science and machine learning workload for you. And at the same time, you need that mathematical intuition in order to make specific decisions that are really going to impact the quality of your analysis. In terms of the particular ratios or the amounts that we got to deal with, fortunately, the major was in fact flexible enough to give students the option to choose like what kind of a specialized education would they like to have within the data science major. And with some of the electives, with some of the elective options that we had, some people opted for more CS-oriented classes, related to signal processing, or let's say like other kinds of topics. And some people, in fact, opted for more mathematical concepts like convex optimizations and things like that. Some topics that I'm just remembering off the top of my head, where students basically kind of made the decision on the kinds of specific areas that they would like to kind of spend more time on or spend more time learning about. And this could also be related to what their ambitions look like. Let's say if someone wants to get into research, maybe they would want to take a different set of electives, or maybe they'd like to delve more into the theoretical aspects of data science, and things like that. Of course, this can vary depending upon person. And so really having this flexibility in the major really helped a lot in terms of choosing particular kinds of areas that we would like to focus on.
Right, definitely. So now I sort of wanted to transition into your experience as a data scientist working in the industry. So as of now, I mean, you've had some internships and you just started working around half a year ago for Microsoft. So how has that been? What's been your day-to-day life as a data scientist?
Yeah, so I'm actually working at Microsoft as a machine learning engineer. And I'm part of a rotational program, a machine learning rotation program, where we work with 4 different organizations across Microsoft on different kinds of ML projects. And then at the end of the rotation, at the end of 2 years, we get to choose whatever org or team we would like to join out of all the experiences we have. So really the principle here is kind of dealing with the first 2 years of the rotation program as a learning opportunity to kind of get acquainted with different kinds of machine learning work across the company, and how things kind of work at the scale of Microsoft and things like that, and dealing with different kinds of research-oriented and product-oriented challenges and projects as well. Related to my day-to-day as a machine learning engineer, I do get to work cross-collaboratively with other data scientists and other PMs in the program itself. And we also interface with a fellow team or a fellow organization that we are rotating with inside of Microsoft itself, where we try to accelerate some of the AI machine learning work for them. And even with a machine learning engineer or a data science, we can dabble into either the engineering aspect or the scientific aspect of things as well. Of course, the proportions can vary depending upon your role. In terms of my day-to-day, of course, more of my work is surrounding engineering and building software and systems and pipelines in order to facilitate different parts or components of the overall machine learning lifecycle. That's really what my day-to-day kind of looks like. And my day-to-day kind of also involves interacting with a variety of like stakeholders, whether it be people on my team in the rotation program or the fellow organization that we are dealing with, or even some of the leadership or some of the stakeholders that are responsible for taking the output of the project that we are dealing with and things like that.
Right. So I was just about to ask you, what are some of the soft skills along with the technical skills that really help you as a machine learning engineer?
Okay, some of the soft skills that really helped me. I would probably boil this down to networking, communication, and presentation. So networking in the sense that this rotation program really offered me like a great kind of opportunity to network with different kinds of people in my rotation program, and also kind of learn about some of the projects that they are doing with their fellow organizations in order to kind of get a bird's eye view of how machine learning happens at Microsoft. And this networking component also kind of helps me make more friends, get to learn about more people, learn about different kinds of work, and also kind of learn about different kinds of opportunities that are there existing inside the company's ecosystem. The second part is communication. And I don't just mean like official communication or let's say talking with the leadership team, but also dealing with day-to-day communication, something as simple as collaborating with your teammates, handling disagreements, even writing emails to other people, explaining your work and what that entails, and discussing next steps. So really kind of engaging in that day-to-day communication and that constant feedback loop in terms of how things are going and what more we can do, kind of really helped me to make sure that I can work with people of different backgrounds with different kinds of expertise, and make sure that my communication is clear enough for a broader audience to understand the context of. And last but not the least, I really think that I learned a lot of presentation skills in my role as well, in terms of presenting to a variety of leadership team, a variety of stakeholders associated with my project. And we kind of got the opportunity to make formal presentations at least once or twice, let's say every 2 weeks, for example, as part of the project itself, to make sure we are able to effectively communicate the bottom line of what we are doing and what kind of impact it is having. And even outside of my project, I am able to leverage the company ecosystem to give talks outside of my fellow organization as well, in terms of some of the past experiences that I've had and how those could kind of potentially also help other people. Really having that culture of being able to talk about different ideas kind of really helped me express my thoughts in hopefully a more coherent way, and also kind of exercise my presentation and communication skills, because this would be really key for like pretty much every employee, especially with a field as technical as machine learning.
Wow, that's amazing. So what are some of your future prospects, or like what are you looking to do in the future? Do you want to continue working as a machine learning engineer? Do you have some other fields inside data science you want to explore before you actually make a choice? So what's that
Yeah,
like?
that's a good question. So I don't exactly have a specific field in mind, because of which I'm happy that I get to explore things in the rotation program and really kind of take my time getting acquainted with different kinds of areas and really make my decision. Especially as I'm this early on in my career, I want to make sure that I'm able to explore as much as I can and then kind of make any decisions on particular areas I would like to delve deeper into. In terms of my immediate future prospects, I definitely plan to go through different kinds of experiences, learn about different aspects or kinds of ML projects that I can get experienced with, and also trying to decide particular areas that I would like to focus more on, while still being a machine learning engineer, because I personally believe for myself that there's already a lot of new things that I simply don't know enough about, that I'm simply not an expert of. And there's a lot of untapped things that I can really learn about here, where even in the foreseeable future for now, I can kind of see myself working on different kinds of ML challenges, learning about different kinds of use cases on how machine learning is applied, and also learning about the software engineering components on the side in terms of writing software that is like cheaper, faster, more scalable for these kinds of applications. So there's already, I feel like, a lot of untapped kind of knowledge, or really this knowledge resource that I haven't tapped into too much, that I can really get to explore and also learn more about. So for now, I'm really just kind of in a learning and exploration phase.
Yeah, and that's really important because it's hard to make a decision until you actually explore a lot of stuff, find out what you actually like. Because I'm interested in math and CS right now, but I'm also taking some economics courses. I'm also taking some psychology courses, finance courses, So let's say I find something really interesting, I'd be happy to switch over. And same goes with you as a working professional. Of course, you'd want to actually explore the different fields before you make a choice. So I have a question this is actually a question from a listener, and they wanted to know about the career path as a data scientist, data analyst, all that related stuff. So what is their path in leadership and individual contributor role? So would you be able to climb up the leadership ladder and still be in the field of analytics and stuff like that?
So it can be a little tricky for me to answer that question first, considering how early I am into my career as well. And considering that data science is still a very emerging field, even though some of the kinds of work that we now call as data science has also kind of been existing in the industry as much as like 30 years back. It is kind of difficult for me to answer that specific question, but if I had to take a stab at it, I would definitely say that knowing how to process information in a more data-driven way and able to take decisions from that seems to be a very core component of how you can potentially impact an organization at scale, or at least that's what I personally got to observe with my limited experience. So if you are able to, let's say, if you happen to be in the data science and machine learning field, I feel like it's already a pretty diversified role where you're not only engaged in the technical challenges surrounding data science and machine learning, but you're also getting to collaborate with a variety of stakeholders, technical and non-technical, to kind of explain the bottom line of your work and how it impacts the bottom line of the organization. And so really kind of engaging in a diversified role like this can really kind of help you look at things from a technical lens as well as from an organizational lens as well. And later on, this can hopefully provide us with a better data-driven intuition in terms of being able to take more broader scoped decisions on how an organization can be positively impacted by the power of data, by the power of machine learning, and by kind of processing all the information around us and trying to kind of find some sort of a structure with all the chaos or all the phenomena that are happening around us. So I feel like really the diversity of this role can kind of be very crucial to being able to take coherent, logical, and safer decisions later on as well.
Perfect. That's really insightful. So thank you so much, Advitya. These were all the questions I had. If you want to add something to the interview, please feel free to do that now.
Yeah, the one thing that I would really want to add, just kind of related to an answer I gave just now, was like especially for college students or high school students or even younger industry professionals who are very early on to their career, there really is no there really is no absolute need to kind of limit yourself to one particular kind of work. I feel like a lot of people in our early 20s or kind of early on in our career or in college really have the liberty to explore different kinds of topics that we're simply curious about, and also trying to take risks if you want in terms of exploring particular kinds of topics, even if particular kinds of things don't work out exactly the way we had anticipated. This would still really help us kind of like learn from different kinds of experiences and just have a more diversified perspective on different kinds of things, which can help us in our overall longer term career journey, is the kind of hint that I got, and some of the insights that I also got from other more experienced people. So it's really just about being curious about other things. You don't need to be interested in a particular field, and just trying to see what you like to do, because if you like what you're doing, that'll just automatically can make you pretty great at it, and you can also derive other kinds of value from it. Yeah, like whether it be like, let's say, monetary value, or let's say the value of like interacting with other people and things like that. So really just being curious and learning and trying to see whatever you like and trying to drill down into it will ultimately serve you well, and you will get positive experience or a good learning experience either ways.
Great. Thank you so much for joining us today. And it was amazing talking to you.
Yeah, thanks a lot for having me, Krish. I had a great time chatting.